Today, we are going to write unit tests for our container. This is the third video in the Dependency container series. So if you haven't seen the first two videos, I left links in the description below, so make sure to watch those first. Okay, let's get started. First, we need to add the test target. So I'm going to come here and select File, New, Target. It's going to be Unit Testing Bundle. You're going to say Next, and it will name the tests by appending tests to the project name. You can finish it. So by default, it's going to give us a test file with the same name of the target. But we are going to write the test for dependency container, so we can rename it as dependency container tests. Also copy it and paste them here in the comment, and also for the test name. We can get rid of all the default example methods. And just for now, we can just say func tests, just to be able to run the tests on a simulator as an empty test to get the compiler ready. Cool. So now while it's building, first, as you know, in dependency container, we have two different ways of registration and resolving dependencies, like a single instances, or we can also register closures and resolve them as well. So let's write tests for making sure the registering a single instance and resolving it works fine. So we can get started with that first. So I'm going to come here and say func test single instance registration. And here we will be writing our test. But first we need to create some protocol and also some dependency that conforms that protocol. So we are going to be able to register and resolve something. So I'm going to come here, I'm going to right click, I'm going to say new file. Let's say it's going to be single instance dependency. So let's add the protocol first, single instance dependency protocol. And it will have a test single instance method requirement. And we want to make sure that anything that's conforming to this is any object. So you'll have this constraint here. And I'm going to come here and say final class single instance dependency that conforms to single instance dependency protocol. And we can also implement the method here, but the body will be empty because it's not needed. Okay, so now we can write our first test. So single instance registration. As you can see, I'm writing snake case for test names, unlike regular method names in the main target, because I think it makes it more readable this way, as the test names tend to get longer usually. Okay, so now let's create the instance for this new dependency we just created. So let's say let my instance is equal to single instance dependency. So we initialize it here. And then we're going to talk to the dependency container to register it. But before we can do that, we need to import our main target here, testable import dependency container starter, the project name. So now we can interact with the container. Before we do that, I'm going to show you something in the container. So as you know, the dependency container has a single instance and it has a private initializer. So because of this, we cannot initialize it. I mean, this is something we want, right? We only want to have one container in our approach. But also that means when we write unit tests, we're also going to be interacting with the shared container. So when we register some stuff inside the container in one test, and then in the next test, those registrations will still be available in that container, which is not so nice, because ideally we shouldn't have any leftovers. But for the sake of this container, that is fine. So it will not affect it in any bad way. But in general, it's not a good practice to test it like this. So if this was a modularized project, so if the dependency container was in its own package, we would just make the container public, make the shared instance public, and the methods also public, but we could keep the initializer internal. By making it internal, we could write tests in that package, and we could access to that initializer. So in our tests, we will be able to initialize a new dependency container for every test case, so we wouldn't need to worry about any leftover data in the single shared instance. But since this is not a modularized project, so everything is in the main target, we cannot do it. But I just wanted to mention this to you, so if you add this as a package, you can test it in a better way. Okay, so now let's continue with our tests. I come back to our test file. So we initialize our instance. So now we're going to register it. So I'm going to say dependency container dot shared dot register. Type is going to be a single instance, and then the instance is going to be here, what we just created. And the protocol is going to be single instance dependency protocol dot self. So for this protocol type, I want to register this instance. Okay, that's cool. Now we are done with the registration. And now let's try to resolve it back. So I'm going to say let resolved equal to dependency container dot shared dot resolve. Type is going to be single instance for this protocol, single instance dependency protocol dot self. So for this protocol, get me a single instance. Okay. And then in the end, if everything works fine, if registration and resolving works fine without any problems, what we can do is let's make sure this resolved and my instance are the same objects in memory. So we can make sure that we are getting the actual instance to be registered. So I'm going to come here and say xct assert true. And the expression is going to be my instance 3 equal signs resolved. What 3 equal sign does is it makes sure these two objects are the same objects in memory. It's not like 2 equal signs where we could have 2 different objects and we could see if they are equal to each other with their properties, like with equatable. But this is about the checking them if they are the same in memory, which is actually what we need for this test. So now I'm going to run this test to see if it's working fine, the registration and resolving works fine, and what we get is indeed what we registered. Cool, it succeeded. So for the single instance, the registration and the resolving works fine. Okay, great. So now we can move to the next test to test the closure-based registration and resolving. So I'm going to come here and say func test closure registration. And here we need to register a closure and then resolve it later on. So we need a different kind of dependency here. So let's say I come here and create a new file in the test target. I'm going to say new file, and let's call it closure dependency. So now let's create a protocol first, closure dependency protocol, which will have a method test closure based dependency method. And let's implement a struct closure dependency that conforms to closure dependency protocol. And here, of course, let's implement the method as well. And the method body can be empty. So since this is closure based, it can be anything, right? So that's why we are using struct. And ideally, as you'll see soon, every time it's triggered, it will return a new instance of closure dependency. So, okay, our protocol and the struct is ready. Let's go back to tests. And here, let's create the closure. So let my instance providing closure. So it's type that takes nothing, disclosure, but it provides the in the end closure dependency protocol. And in the closure body, we can initialize the closure dependency. So every time this closure is triggered, we get the new closure dependency. Okay, so now we have this closure ready. Let's register it to our container. So dependency container dot shared dot register. Type is going to be closure based, and the closure is going to be my instance providing closure. And for type, protocol type closure dependency protocol dot self. Okay, so now we could register it, and let's see if the resolving will work fine. Here we don't need to compare anything in memory because we're just going to be getting a new instance anyways when the closure is triggered. So we can directly say let underscore is equal to dependency container dot share dot resolve, and type is closure based, and for closure based dependency protocol dot self. That's it. So if this works fine, we will know the registration and resolving works fine for closure based dependencies. So let's run this as well. Okay, build successfully. Cool. So test succeeded. So now we can also see the registration and resolving works fine for closure. Okay, but there's one more test I want to write, which is actually an important one for a scenario that a dependency is needed to be provided from the closure, but that dependency depends on another dependency. So from the closure, we are going to talk the dependency container again. So while we are synchronizing in our custom queue, we're going to call synchronize again, but it's going to be fine because our queue is concurrent. So when the resolve is triggered for that closure, so when we call that closure inside this queue with sync here, and then within the closure, if we call the resolve again, we're going to come to the queue and to sync again, while we are already synchronizing with it. But since it's a concurrent queue, that will work fine. But I just want to make sure it's really going to be working fine. So to make it easier to understand, let's imagine we have two dependencies. We have a networking dependency and we have analytics dependency. So analytics also depends on networking. And analytics, for the use case, whenever it's resolved, we want to create a new analytics instance, but networking, there's always going to be one instance. Okay, so now let's write the test for it. So that we will say func test resolving another dependency within closure before returning from closure. So as you can see, this test is pretty descriptive, but it's pretty long. So since it's snake case, it's easy to read. Okay, so we need to create this networking and analytics for inside the tests to simulate the scenario I just described. So we're gonna come here and create a new file, and let's name it test networking. So it's gonna be protocol test networking protocol, and make network request. Of course, ideally it will take some parameters here, but for the sake of this example, it doesn't matter. And then let's implement the networking itself. So test networking class that conforms to test networking protocol, and also implement and make network request. Okay, so the networking is set up, and now let's create the analytics. So I'm going to create another file, and let's name it test analytics, and let's name it the protocol test analytics protocol, and the method is going to be track event. And then let's implement the actual implementation, struct test analytics that conforms to test analytics protocol, and it will implement the track event method. But this analytics, as I just described, also depends on the networking. So we can say private let networking. In the protocol type, it's going to be test networking protocol. And we can come here and say initializer. And then in the initializer, we inject the networking and then set the networking. And we can leave the method empty here, but yeah, just to be complete, let's say networking that make network request. So we are interacting with networking. Okay, so now we also set up our analytics. So if I go to dependency container tests and continue with our final test here. So now let's first register our networking in the container. So let networking instance going to be test networking, and then we can come here and say dependency container share register type single instance, and networking instance is here, and the protocol is the test networking protocol itself. Okay, so we register our networking similarly to our first test case. And now let's create a closure to be able to register analytics and provide it from the container. So let's create a closure, let analytics providing closure. The closure type takes nothing and returns test analytics protocol. Then it's going to be equal to closure here. So as you know, we can return the test analytics here, but we first need the networking. So from within the closure, we are going to say let networking is equal to dependency container dot share dot resolve. Type is going to be single instance, and the expected protocol is the test networking protocol dot self. So first we get the networking, then we can return the test analytics by injecting this networking here. So in the closure, we are providing the implementation of analytics. So every time someone needs the analytics that conforms to test analytics protocol, we will be providing a new test analytics. Okay, let's register this closure as well in the container. The dependency container that shared that register type is closure based, and inject the closure here. And the protocol is going to be for the test analytics protocol dot self. So we now make the registration. So first we register our networking, and also we register our closure that provides analytics. Okay, so now we can see we can actually successfully resolve it. So again, we can say let underscore equals to dependency container dot share dot resolve. Type is going to be closure based, and I want to get the test analytics, something that conforms to test analytics protocol dot self. So now if this runs successfully, that means it's working fine as expected, and it's okay if we're calling synchronize again for providing dependency from the closure by getting another dependency from the container. So let's run it and see if it will run successfully. So cool. So the test succeeded. This is also working fine. So we can indeed call synchronize again on this queue because it's concurrent. So just to see it, if I comment here, remove this comma here, so now we don't make our queue concurrent. And if we run the test again, the final test, and let's see what happens this time. So now we're running it, and now we're going to have a crash in our containers resolve method when we try to synchronize, because we are in the closure here, as you can see. Like that means we are already in the queue, and when we call the resolve from the closure, we try to synchronize again, which will result in a deadlock because this queue cannot run concurrently, right? The thread is already blocked. So this also shows us that actually this attribute, the concurrent attribute, is helpful for our use case, and our test actually verifies that it's run successfully. So now I take it back, I uncomment this line. So if I stop now and run the test as before, it will run successfully, it will succeed. And yeah, that's it. So now we can see that our registration and resolving works fine, and also for a case where we depend on another dependency inside the closure. So finally, let's run the whole test together and see everything is working fine. Yep, it does. You can go here to coverage, and we can see our dependency container has like 93.2% coverage. And if we jump there, we can see the only lines that are not tested are the fatal error lines, which is expected because we didn't try to resolve something we did not register. As far as I know, there are some ways to be able to test these fatal error scenarios as well, but it's not something I explored in detail. So that's why I'm also fine with not testing them. But if you're curious, you can check out how to do it. But yeah, apart from the fatal error scenarios, we have covered everything. So registration and resolving. So yeah, that's it. So we are done with our dependency container tests. Yeah, so if you like the video, please hit the like button. And also make sure to subscribe so you will get notified for the next video, because next time we are now going to start using the container in the main project. And while doing so, we will also explore some potential scenarios where things might go wrong. So yeah, see you next time.